Hello and welcome to VLC 101, What's New in Amazon Managed Blockchain. My name is Emil Basil. I'm a senior blockchain architect on the AWS Professional Services team. Over the next 30 minutes, I'll be covering three topics. We'll begin with a brief overview of Amazon Managed Blockchain and the benefits it offers over managing your own blockchain networks. Next, I'll give an overview of Managed Ethereum, which became generally available earlier this year. We'll look at what the service offers and walk through a sample architecture. And lastly, I'll touch on what's new in Managed Hyperledger Fabric. And we'll also look at a sample architecture of a Fabric application running on Amazon Managed Blockchain. So let's begin. What is Amazon Managed Blockchain? In industry, a significant portion of today's business is conducted in a multi-party environment where workflows span multiple organizations. You can think of supply chains and financial transaction settlement, where multiple parties are involved in transactions or business events where data must be shared between parties. Historically, many of these workflows have been facilitated using manual or paper processes that reconcile information to a privately held system of record within each organization. These siloed systems of record and manual processes often lead to operational inefficiencies or require a trusted third party to help facilitate the business process. Blockchain technology, however, is well suited to enable a shared system of record for transactions and business events that occur between multiple organizations. Using a blockchain network, each party in a multi-party business process is able to share data and interact on a common network that serves as a single system of record or a source of truth. This has led to exploration into blockchain as a means by which to address inefficiencies and challenges with a wide breadth of multi-party business processes, such as provenance and track and trace and identity with provable and portable verifiable credentials, as well as fractional ownership and digital rights management. Using programmable logic executed in the context of the blockchain network, colloquially called smart contracts, business logic can be facilitated amongst the multiple parties on the network in near real time, providing a time-stamped and immutable ledger of the state of data and events, both past and present. However, to build out these high-impact use cases, most organizations begin with a proof of concept or a pilot solution on the path to production. And there are distinct challenges with exploring and scaling blockchain solutions that Amazon Managed Blockchain can help alleviate. When you embark on your blockchain journey, the prerequisite step to experimenting with a proof of concept for a given use case or organizing a pilot solution amongst partner organizations is setting up a blockchain network on your desired infrastructure, which can be complex in and of itself. The challenge of setting up blockchain infrastructure often stands in the way of building out use case specific components for a given solution. Whether you are starting with a private blockchain or connecting to a public blockchain, setting up a blockchain network can be challenging. Most open source frameworks have a lot of configuration options and require you to stitch together a lot of infrastructure to get started. This can include networking, configuration, testing, and much more. From there, as the network grows or experimentation expands, it can be hard to scale the network, whether that's adding new members to join the private network or managing the growing storage requirements for your network peers, amongst other challenges. And as you scale, the effort required to maintain the network also grows. So managing security, managing governance, managing the data, the billing, all of this either requires automation or manual effort to address these challenges. And given the multi-party nature of blockchain networks, the complexity of managing the growing network infrastructure increases very quickly. And with these challenges, of course, comes additional cost. whether you use consultants to build and maintain your blockchain network or you use internal resources to do it, it can become expensive to build and maintain the blockchain network yourself. So with these challenges as a backdrop, you might be thinking it might be valuable to have a service that will take care of these underlying blockchain infrastructure responsibilities for you. Well, that is what Amazon Managed Blockchain can help with. Amazon Managed Blockchain is a fully managed service that makes it easy to create and manage scalable blockchain networks using popular open source frameworks. Today we support Hyperledger Fabric and Ethereum. So what is Amazon Managed Blockchain? It is a fully managed service, which means you do not have to worry about underlying infrastructure, and you can set up a network in minutes versus requiring hours or even days to set up a blockchain network on your own. It is based on popular open source projects where we have added management features on top of those open source projects. We have also simplified working with governance features of the blockchain network by enabling customers to achieve this via the AWS console or via APIs. So things like managing your network membership, inviting others to join the network. All of that is simplified through APIs and things like that. We've also designed it to be very reliable and scalable by using some of the same technology that powers many of our other large AWS services. It has a very familiar pay-as-you-go cost structure with no upfront investment required. And it is tightly integrated with many of our other AWS services, such as KMS, CloudWatch Logs, CloudFormation, to name a few. For example, it's very easy to build an event-driven application that runs on top of AMB. All of this is easily accessible via the management console, the command line interface, the API, or CloudFormation, and is much easier than trying to set this up on your own infrastructure. Now that we've looked at Amazon Managed Blockchain, let's take a look at Managed Ethereum. So Amazon Managed Ethereum provides fully managed Go Ethereum clients. And a Go Ethereum client, is also known as the Geth node, is the most popular Ethereum client on the public Ethereum mainnet. As part of the fully managed aspect of the Geth node, we automate monitoring and recovering from node sync failure. So if your node were to die or become unsynchronized from the network, we handle all of that for you. We also automatically patch the node with any security updates, as well as upgrading the nodes for any upcoming hard forks. So for example, we recently updated all of the Ropsten test nodes ahead of the upcoming London hard fork that is scheduled for mainnet over the next few weeks. All of these are things which you would need to maintain yourself if you were running your own Geth node, and these all are part of the managed aspect of Managed Ethereum. Running a new node, spinning up a new node, takes less than an hour for mainnet and less than 30 minutes for test networks. So it's very quick to get up and running with a node, or adding a node to your existing set of nodes if you want to have add additional scale or spin up in a different availability zone or region. There's also faster sync times because of how we are spinning up the new nodes in the back end. And also, importantly, for Ethereum, the node storage space is automatically scaled for you. So Ethereum is constantly growing. There's a new block every several seconds. And so there's a need to sort of continually maintain the storage space. So all of that is managed for you. Here are a handful of customers that are running on Amazon Managed Ethereum. Now let's look at what Double Jump Tokyo has done on AMB. So Double Jump Tokyo is a gaming company out of Japan, and they launched a wildly successful game called My Crypto Heroes. And they are hypersensitive to uptime and cost savings. And in May of this past year, a couple months ago, they had the highest volume of transactions across all games running on Ethereum. And they had been having difficulty with maintaining stability of their Ethereum nodes and had also been paying a lot for the maintenance of these nodes. With Amazon Managed Blockchain, Ethereum, they were able to quickly spin up Geth nodes on Ethereum mainnet and achieve high availability with no upfront investment required on their end. And they can now easily scale their nodes up or down as needed while they're only paying for nodes that they are running. Now let's look at a typical application architecture running on managed Ethereum. So this is a sample reference architecture, but it would work for many decentralized apps that are running on Ethereum on Amazon Managed Blockchain. So let's start on the left side. So on the left side, you have CloudFront and S3, where you store your client-side application. This is very similar to many web apps and client-side apps like your React app or something else like that. That's all very similar there. Then we have an API gateway, which receives the requests from the client-side app. And API gateway sends this to one of two places. It'll send it either to a Lambda function or to AWS AppSync. First, let's look at the Lambda function. So the Lambda function is multi-purpose, meaning we can use it in one of two ways. The first way is as a transaction relay. So let's say your application is a Web3 application where your users are using a wallet like MetaMask or something else to sign transactions. These transactions will be sent to the Lambda function, and the last thing that they will need before they can be sent to manage Ethereum is they need a SigV4 signature on there. And so Lambda will retrieve the IAM credentials from Secrets Manager, use those credentials to sign the transaction, and add the SigV4 signature to it and send that to managed blockchain. In the second scenario, let's say that the users are not signing transactions with the wallet, and instead we want to sign the transactions for them on the back end. In this case, the application would send the API request to API gateway, which would send it down to Lambda, and Lambda would retrieve those signing credentials from Secrets Manager, sign the transaction, and send that over to AMB, along with a SigV4 signature. So it's pulling the Ethereum credentials from Secrets Manager in addition to the IAM credentials. That's one approach. Another approach you could do for that scenario is you can use AWS KMS, the key management service, to sign the transactions. And the benefit of doing that is the private keys never have to leave KMS. Whereas with Secrets Manager, we would be securely storing them in Secrets Manager. And for high availability and fault tolerance, the managed Ethereum nodes can be run in multiple availability zones. And the Lambda function can round robin across these nodes. And you could even extend the Lambda function to do health checks for the different peers and things like that if you want to extend this architecture. But now let's go back to the left side. Let's go back to API gateway. The other route it can go is via AWS AppSync. And it would do this, for example, if it needed to query some data on the blockchain that wasn't efficiently searchable by querying the smart contract directly. So, such as looking up an NFT by its address or doing a date range query to find all the NFTs which have been created in the last 30 days. Smart contracts are not designed to support complex queries. They're really good for writing data and making sure that the data never gets deleted or tampered with, but they're not really designed for complex queries. So what we do here is we have a Fargate cluster that is subscribing to an event topic for this contract. And anytime there is an event or any updates to that smart contract or an NFT gets created, anything like that, the Fargate cluster will receive this event and it'll write data to DynamoDB. So now we have an additional data store where we have data from the smart contract and from the blockchain network where we can much more easily write more complex queries. And this data store can be DynamoDB, it could be RDS, it could be any other data store. And so what AppSync will do is it will query this data store to provide the end user an ability to have much more powerful query patterns against the blockchain data. So that's Amazon Managed Ethereum. Now let's look at Managed Hyperledger Fabric. And let's see what's new in Hyperledger Fabric, in Amazon Managed Blockchain Hyperledger Fabric. We have added 1.4 LTS support, which has introduced a few new benefits to customers. The first is customers can choose where their world state is stored in one of two databases. There's a LevelDB as well as CouchDB. And the primary difference there is LevelDB is a simple key value store, whereas CouchDB is a document store. So depending on how you anticipate querying your data and using your data, one might be more beneficial than the other one. There's also now support for anchor peers. And anchor peers essentially allow you to discover other peer nodes running on the network within other members' account. And what this really enables is it enables Hyperledger Fabric Explorer to run on your Fabric network. And what Fabric Explorer is, it's a browser-based application that lets you view transactions as they're happening. It lets you inspect blocks on the blockchain network. So it's a very visual representation of the activity and the state of the network. And this is enabled now with the 1.4 LTS support. And lastly, the 1.4 support also introduces support for private data collections. And private data collections enable you to restrict the visibility of certain elements of data without compromising on the endorsement policy of the contract. So for example, if we have three parties, Alice, Bob, and Charlie, and Alice and Bob want to transact and send some highly sensitive data between the two, they can restrict this data visibility to just them two without Charlie knowing about the actual quantity of goods that was sold or what price they were sold for. But Charlie could still participate as an endorser on the transaction, so you're not losing any of the security of the network. Some of the other things we have added, we introduced CMCMKs, which are customer managed keys from KMS. And using this now, customers can use their own CMKs for encrypting member-specific resources within Hyperledger Fabric. These CMKs are created and maintained inside of AWS KMS, and customers can manage them according to their security policy within KMS. So that is something customers are very excited about. And lastly, we've added support for tagging. So tagging is frequently used for getting visibility into your AWS bill across departments, across different work streams and things like that. But tags can also be combined with IAM policies for much more powerful access control to constrain access to certain resources based on the tag. So in your IAM policies, you can restrict access based on the tags which you want a user to have or not have access to. Here are some of the customers that are running on Managed Fabric. And let's dive into a couple of customer stories here. So the first is Alpha Ledger. So Alpha Ledger is using blockchain to modernize the nearly $4 trillion municipal bond market in the US. Historically, bonds have not been widely accessible to the general public, largely due to the cost of capital and overhead required to participate. There are also several inefficiencies in the bond marketplace, such as the time to settlement requiring 2 days, and a lot of heavy lifting around accessing historic data of bond transactions and activity. Using Amazon Managed Blockchain, Alpha Ledger is making inefficient multi-party processes for municipal bonds and making them near real-time, where everyone has visibility. This helps with market making and making things more equitable for anyone to participate. And it also eliminates many of the operational challenges, including removing long settlement times and getting access to historic data. So the way it works is digital asset bonds are originated on the blockchain at the time they are created, which begins the journey of this asset having its entire history available for anyone to see. So we get transparency of this bond right away. And regulated institutions can integrate and work with these digital asset bonds, while local municipalities may want to run their own nodes and maintain full copies of all of the blockchain data themselves. Participants can be invited to join the Managed Fabric network using Amazon Managed Blockchain's governance features, such as inviting members and voting on membership inclusion. Now let's look at Riverside County in California. Riverside County in California is the 4th largest county in the state and the 10th largest in the US. And they embarked on a journey to deliver citizen-centric services using innovative technology. And this drove the development of a proof of concept and a pilot solution in collaboration with Infosys. The solution uses Amazon Managed Blockchain to manage digital records such as birth and death certificates. The use of paper physical records and manually intensive processing for record management today presented a significant opportunity to illustrate the value prop of a blockchain-based solution for issuing and verifying digital records to the residents of Riverside County. On one end, Riverside County officials can issue certified records to residents as a PDF file, with the hash of this file being recorded on the blockchain. And on the other end, recipients of this digital record can easily verify authenticity through a web interface that compares the hash of the provided document to the hash stored on the blockchain. This solution was used to illustrate the potential operational cost savings and user experience benefits associated with implementing a digital record management system using blockchain, moving to nearly instant distribution and verification of records, in contrast to the paper record keeping process, which can take weeks. Now let's look at a typical Fabric architecture. So on the right side, you have your decentralized application user. And similar to the example we saw with Managed Ethereum, the user is working with a client-side application that is stored in S3 and fronted by CloudFront. This application works through Amazon API Gateway for all of its requests, and Amazon API Gateway sends these off to a Lambda function, which is right in the middle of the diagram here. Now this Lambda function has the Fabric SDK on board the Lambda, and it uses this Fabric SDK to interact with the Amazon Managed Blockchain network, which is in the top part of the diagram up there. And all of this communication happens over AWS Private Link, so the access to the network is only available via this member VPC. And all the traffic happens over the AWS backbone. It doesn't go over the public internet. And the Lambda is used to both read and write to the blockchain network, and the transactions are signed by the Lambda function itself, and it accesses the credentials to sign these from something like Secrets Manager, where you can once again store the credentials in there that are used, and Lambda will just download those at runtime. So at the bottom of the chart, we have another Fargate cluster. So if you remember, we had one in the Ethereum architecture, and similarly, we have one here, and it's pretty much for the same purpose. The blockchain network is great for writing data and keeping it immutable, but it's not great for more complex querying. And so what we're doing here is we're standing up a Fargate cluster that is subscribed to the blockchain network, and it subscribes to one of the peers on the blockchain network. And as activity happens on the blockchain network, as new transactions are written to blocks, the Fargate cluster is notified of these, and it writes the change set, the delta of the data, into DynamoDB. And DynamoDB can be queried directly, but can also be associated with a trigger. So as data gets written to DynamoDB, that can trigger a Lambda function, which can then do any of a number of things, such as triggering SNS or an SQS queue to notify interested parties that maybe it's their turn in a workflow that some document has been uploaded and now they need to review it, or it can send an email, or any other number of aspects. So that's all I have for BLC 101 today. If you'd like to continue learning about or blockchain or any of our other AWS services or anything else within AWS, here are some valuable resources. We have digital training, classroom training, certifications. I personally learned a lot studying for certifications. And if you would like to get a well-rounded understanding of how to deploy on AWS, I would recommend looking at the SA Associate exam. That's a great one. We also have education programs and enterprise resources. There's a link down there, aws.com/training, for more information. And with that, I just want to say thank you for taking the time today to learn more about what's new in Amazon Managed Blockchain. If any of this is of interest, or if you'd like to learn more, here are a couple of ways to contact me. Thank you, and have a great rest of your day.